All right. So problem one was question 2002 Form B, and it was question number 4. And this was a proportion problem. And this is actually a really good one. A really good foundation question. And each person in a random sample of 1,026 adults in the United States was asked the following question: based on what you know about the Social Security system today, what would you like Congress and the president to do during this next year? Response choices and the percentages selected by them are shown below, and they gave the list. It says find a 95% confidence interval for the proportion of all United States adults who respond, make some major changes. Right, so we care about make some major changes. To the question, give an interpretation of the confidence interval and give an interpretation of the confidence level. Now, I'll be perfectly honest with you. They don't have to tell you to interpret the interval. You have to do that every single time. This part, we'll address that in a moment, you'd only have to do if they ask you. So the confidence level, you only have to do if they ask you. If you always do it, it's not wrong, but the interpretation of the interval must be there every single time. So they want us to use make some major changes. Well, they took a random sample, and this right here is my p hat. All right, that is my p hat. So we always need to start off by defining our parameter and let p equals the true population proportion of U.S. adults who respond make some major changes. We write our formula, and if you use Q, make sure you include 1 minus p. Alternatively, you could have written p hat plus or minus z star, pinking out, of course, p hat times 1 minus p hat over n. That way you don't have to define Q, but I like using Q, but that's up to you. But if you use Q, you need to have to show this statement. So we always need to give our conditions. Simple random sample of 1,026, and that was given. We need to test to make, since we're sampling without replacement, we need to make sure that our sample is small enough so that things remain independent. So in this case, n is less than 10% of the population. Our sample size was 1,026. So I divide it by 0.1 and I get 10,260, and there are at least 10,260 adults. You could have alternatively just multiplied by 10 and that would have worked as well. Once again, I know I say this over and over again, but I don't want you to forget this is the giant pile of M&Ms. I take one M&M out, I eat it. Technically the percentages changed because I didn't replace it. However, it's such a small amount that we say it's independent enough. And that's what that rule is for, is to say it's independent enough. Then we need to make sure that our sample is large enough to use the normal approximation. So NP hat is greater than 10. So we have 1,026 times 0.39, and it's approximately 400. I rounded, all right? NQ is, needs to be greater than or equal to 10. So 1,026 times 1 minus that equals 626. Both of those are greater than 10. So the sample is large enough to use a normal approximation. I made this note off to the side. This is extremely important. When you go to your calculator, n and x must be whole numbers. Well, when I multiplied, these weren't whole numbers. They weren't. So you're going to have to round. All right? Now, the question is, how do you round? For this case, when you run into this type of problems, I'd recommend you round the way you learned how to do in elementary and middle school. Greater than 0.5, round up. Less than 0.5, round down. However, they really don't care. The main thing is you need to round, but you're going to get a more precise answer if you follow those rounding rules. So if we'd gotten 399.5, hold on, all right. Making sure I was messing up. I hope I got everyone admitted. Anyway, if we had 400, if we'd had 400.3, we would have rounded down. So that's the way I would have approached that. And so anyway, this case, both things qualified, so the sample is large enough to use the normal approximation. And essentially, we're using the normal approximation for the binomial because you're working with a proportion. So consequently, this is technically a binomial, but because it's large enough, we say the sample is large enough, we get to use a normal. All right, so we plug in to our formula, p hat. I need to calculate z star, and this is just as a reminder. Second vars, inverse norm, they wanted a 95%. So 1 minus 0.95 divided by 2, 0 and 1, and we end up getting 1.96. Then 0.39 times 1 minus that, or 0.39 times 0.61, divided by the sample size. And this would be our interval within rounding. So, our conclusion. We are 95% confident that the true population proportion of all adults who respond make some major changes lies within this interval. We should do that every single time, regardless whether they asked for it or not. The next one they didn't ask for. They said explain the confidence level. So in that case, in repeated sampling or in the long run, we would expect that our method would capture the true population proportion of adults who respond, make some major changes 95% of the time. In other words, we're telling them our method is so confident, or we're so confident in our method, it's going to capture the parameter, which in this case is a population proportion, 95% of the time. Last part of this. And by the way, you could have missed the entire top part and still possibly gotten this last part correct. All right? So don't give up on a problem. Always try to answer it. So an advocate for leaving the system as it is now commented. Based on this pool, or based on this sample, only 39% of adults in the sample responded that they want to make major changes to the system, while 41% responded they want only minor or no changes at all. Therefore, we should not change the system. Explain why this system, while technically correct, is misleading. Well, let's look up at the numbers real quickly. Yeah, 39%. 39% definitely do want to make some major changes. But another 19% want to completely overhaul the system. So in this case, the statement is misleading because the advocate implies that only 39% of the adult wants to significantly change the system, when in fact, 58%, which was the 39 plus the 19, of adults want to make significant changes to the system. So this was pretty misleading statement by saying only 41% that wanted to make, only 39% wanted to make major changes. No, as it turns out, well over 58% wanted to substantially change the system.